Breathe in, slowly, and let yourself drift. You are no longer on Earth. You are floating, weightless, far above the silver-blue curve of the world, where the air thins to velvet nothing, and the only sound is the gentle rhythm of your own heart, soft, steady, eternal. Look around you. The sun is a quiet lantern behind your shoulder, spilling pale gold across 1 billion silent kilometers. Ahead, the Milky Way rises like warm milk poured across black marble, every star a sleeping ember in an endless hearth. And yet, beneath this perfect stillness, something is moving. Not planets, not stars. Something far quieter, far older, and far more rebellious. 13.8 billion years ago, the universe began with a flash so bright enough to shame every sunrise that would ever follow. In that first impossible heartbeat, everything, all matter, all energy, all future possibility was squeezed into a point smaller than the period at the end of this sentence. Then it let go. Space itself began to stretch, carrying galaxies away from one another like leaves on a widening river. For centuries, we told ourselves a tidy story. We said the expansion would gradually slow, pulled back by the gentle hand of gravity, the way a ball thrown upward eventually falls. We called this future the Great Slowing, perhaps even a great crunch, where everything might one day return to the embrace from which it was born. But the universe had other plans. In the late 1990s, 2 teams of astronomers, watching distant supernovae flicker like candles across the void, noticed something that should not have been possible. Those candles were too dim, too far. The only explanation that fit every measurement was that the expansion of space was not slowing at all. It was accelerating, growing faster with every passing moment, as though an unseen hand had pressed down on the throttle of reality itself. The astronomers checked their math 100 times. They re-observed, they lost sleep, and still the data whispered the same impossible truth. Something is pushing the universe apart, faster and faster, and we do not know what it is. They gave it the gentlest possible name, dark energy. 70% of all the energy in existence, completely invisible, perfectly smooth, spread with ghostly evenness through every cubic meter of space, and it is winning. Gravity wants to pull things together. Dark energy wants to tear everything apart. And right now, dark energy is stronger. This is the greatest silent rebellion in cosmic history. Not a war of fire and light, but a patient, relentless drifting away of everything from everything else. Galaxies that once danced together in vast clusters will, in the deepest future, find themselves alone in an endless night, unable to see any neighbors at all, because the light from those neighbors will never again reach them. The universe is not merely expanding, it is choosing solitude. But what almost no one realizes is how young this rebellion actually is. For the first 9 billion years after the Big Bang, gravity was comfortably in charge. Dark energy existed, yes, but it was so feeble that it barely registered, like a breeze against a mountain. Matter clustered into great walls and filaments of galaxies, luminous threads stretching across hundreds of millions of light years. The cosmic web was born, delicate and magnificent. Then, roughly 5 billion years ago, around the time our own sun was coaxing the first oceans onto the young Earth, something changed. Dark energy crossed a threshold. It grew from a whisper to a wind, then to a tide. The balance tipped. The rebellion began in earnest. We used to think dark energy was constant, the same strength everywhere, forever. a number written into the foundations of physics by the hand of creation itself. A cosmological constant, Einstein's famous greatest blunder that turned out to be no blunder at all. But in the last few years, everything we thought we knew has begun to tremble. In 2025, the Dark Energy Spectroscopic Instrument, DSI, perched high in the Arizona desert, finished mapping the positions and distances of more than 40 million galaxies, stretching back 11 billion years into the past. And when the scientists poured those positions into their quiet computers, the answer that came back was not a single gentle number. It was a curve, a soft, undeniable evolution. Dark energy is not constant, it is changing, growing slightly weaker in the ancient past, or perhaps slightly stronger today. The measurement sits at 4.2 sigma, a whisper away from discovery, but already enough to send ripples through every cosmology department on Earth. If this holds, an early 2025 reanalyses of Planck's final PR4 data are leaning the same way, then the rebellion has a plot twist even grander than acceleration itself. The strength of the push is shifting with time. Imagine the universe as a vast, dark ocean. For billions of years, the tide was ruled by the moon of gravity. Now a second moon, invisible, unknown, has risen on the opposite horizon, pulling the water in the other direction. And that second moon is quietly changing its distance from the sea. We do not yet know why. Some physicists speak of new fields, gentle as thought, rolling across the vacuum. Others murmur of quintessence, a substance that evolves like the breath of the cosmos itself. A few, in the privacy of late-night blackboards, even dare to rewrite gravity on the largest scales. But the consequence is breathtaking. If dark energy continues to evolve, the deepest future may not be the cold, empty heat death we once imagined, where everything simply spreads into frozen nothing. It could be something far stranger, a universe that one day stops expanding altogether, or one that tears itself apart in a sudden, violent big rip, where space itself is stretched until atoms can no longer hold hands. We stand at the edge of that mystery tonight, you and I, drifting together above the world. Look down for a moment. See how small the Earth has become. A pale blue lantern shrinking behind us. Even our sun, that fierce furnace we once thought eternal, is already middle-aged, quietly burning through the hydrogen in its heart. In 5 billion years, it will swell into a red giant, swallowing Mercury, Venus, and perhaps the inner edge of Earth herself. Long before then, the accelerating universe will have carried every other galaxy beyond our horizon. The night sky of that far future will be almost completely dark, sprinkled only with the ancient stars of our own Milky Way, soon to merge with Andromeda in a slow waltz of fire. And yet, even that sky will lie to its inhabitants, because the cosmic microwave background, the faint afterglow of the Big Bang itself, will have cooled to a temperature indistinguishable from the void. Future astronomers, if any remain, will measure the emptiness around them and conclude with perfect logic that their lonely galaxy is all that has ever existed. They will have no memory of the billions of others that once glittered beside them. The rebellion will have succeeded completely. But here, now, in this gentle moment with you, we still remember, we can still see. Turn slowly. Let your gaze drift along the great wall of light that is the Hercules Corona Borealis Great Wall, a structure so vast it takes light more than 10 billion years to to travel from one end to the other, a wall built before dark energy began its quiet coup. Watch how the Bullet Cluster, where two titanic clusters of galaxies collided billions of years ago, and the hot gas, visible in soft pinks and purples, was stripped away, while the dark matter sailed straight through, untouched, revealing its presence only by the way it bends distant starlight. Even there, in that most violent of cosmic car crashes, dark energy watched and waited, and somewhere, far beyond the reach of any telescope we yet possess, the very first galaxies are still being born in the distant glow of the early universe, places JWST has only just begun to reveal in 2025, red and ragged and brimming with impossible stars 100 times larger than our sun. All of it, every filament, every void, every quiet heartbeat of starlight is being carried outward on the breath of this silent rebellion. You feel it, don't you? The gentle push beneath everything. The sense that space itself is alive, stretching like warm silk between your fingers. We have only 20 minutes together in this first quiet chapter, and already the universe has confessed its deepest secret. It does not wish to stay together. It dreams of distance, of solitude, of a night so complete that even memory fades. And yet, there is something else stirring in the dark, something the new data are only just beginning to hint at, something that makes even the boldest cosmologists fall silent for a moment before they speak. Because if dark energy is truly evolving, then perhaps it is not the final chapter after all. Perhaps the rebellion is only the beginning of a far greater story, and that story is only just beginning to reach us across 13 billion years of darkness. Right now, let yourself sink a little deeper into the quiet. Let the stars blur into soft halos around you. We have so much further to drift together, and when you're ready, we'll follow that whisper to the place where the rebellion was born, and to the hidden force that might yet turn the tide forever. Close your eyes for a moment. Feel the silence stretch and wait. Because the universe is about to tell you something it has never told anyone before. Let the silence carry you a little further now. The Earth is only a faint blue memory behind you, and the sun has softened to a warm coin resting on the edge of sight. Ahead, the galaxy turns like a slow spiral of diamond dust, and every breath you take feels lighter than starlight. We left each other on the edge of a confession. The universe is quietly choosing solitude, and its rebellion is written in a force that is not content to stay the same forever. But to understand why that confession matters so deeply, we must drift back to the four ancient powers we once believed we had tamed. There have only ever been four forces in nature, four voices that speak every event into being, from the fall of a single snowflake to the birth of a supermassive black hole. Four invisible hands that shape every corner of existence. We named them, measured them, wrote them into textbooks, and then, in our gentle human arrogance, assumed the conversation was over. The first voice is gravity, the patient sculptor. It speaks in the language of curves, bending space the path of light, gathering dust into planets, coaxing galaxies into graceful arms. It is the weakest of the four by far, yet over cosmic distances, it reigns almost alone. We thought we understood its song perfectly. It pulls, always pulls, and never pushes. The second voice is electromagnetism, the restless painter. It gives us lightning across violet skies, the aurora's silk ribbons, the soft click when a magnet kisses a fridge door. It creates every photon you have ever seen, every color that has ever touched your eyes. It can attract and it can repel. And for centuries, we believed its strength was carved in eternal stone, exactly 10 to the power of 36 times stronger than gravity. No more, no less. The third voice is the strong nuclear force, the fierce guardian. Deep inside every atomic nucleus, it binds protons together despite their furious desire to explode apart. It is glamorous in its ferocity, 100 times stronger than electromagnetism, yet so short-tempered it refuses to reach beyond the width of a nucleus. We mapped its behavior with exquisite care at the Large Hadron Collider, watched its particles spray like fireworks, and declared its law immutable. The fourth voice is the weak nuclear force, the quiet alchemist. It oversees the slow transmutation inside stars, turns protons into neutrons, allows hydrogen to dream of becoming helium, and one day iron. It is subtle, almost shy, yet without its patient whisper, the sun would never shine. 4 forces, 4 constants, 4 numbers written into the source code of reality itself. Or so we believed. But what almost no one realizes, even now in 2025, is that every single one of those 4 numbers has begun to tremble. Begin with gravity, the oldest friend we thought we knew. For decades, the textbooks told us its strength is governed by Newton's G, later refined by Einstein's curving spacetime, was fixed forever. Yet in the quietest laboratories on Earth, physicists have spent years trying to measure G more accurately than ever before, and the answers refuse to agree. Some experiments whisper that gravity was slightly stronger in the past. Others hint it is fractionally weaker today. The differences are tiny, less than 1 part in 100,000, but they refuse to vanish no matter how carefully the measurements are repeated. If gravity is truly changing, even by a whisper, then every prediction about the future of stars, black holes, and the cosmos itself must be rewritten. Now turn your gaze to electromagnetism, the force that paints the universe in light. Its strength is governed by a number we call alpha, the fine structure constant, roughly 1/137. A number so elegant that physicists have spent lifetimes wondering why it has that value and no other. In the year 2000, astronomers studying light from distant quasars, light that left its source 12 billion years ago, noticed something unsettling. Alpha appeared to be a tiny fraction smaller in the early universe. The change was barely 1 part in 100,000. Yet by 2025, the evidence has grown to almost 5 sigma when combined with new JWST spectroscopy of the most ancient galaxies. If alpha is drifting, then the speed of light itself may once have been different. The chemistry of stars may have been subtly altered, and the very definition of atom may evolve with cosmic time. Let yourself feel that for a moment. The color of sunlight, the warmth on your skin, the way sodium street lamps glow orange, all of it rests on a number that might be quietly changing as the universe ages. Now come closer, much closer to the strong force. In 2024 and early 2025, the LHC completed its highest energy runs yet, smashing protons together with such ferocity that the fireballs reached temperatures not seen since the first microsecond of the Big Bang. Deep inside those fireballs, quarks and gluons move almost freely in a perfect liquid we call quark-gluon plasma. And in the entropy measurements of that plasma, something extraordinary appeared. The The strong force coupling, the number that tells quarks how fiercely to cling to one another, seems to have been almost 2% weaker in the infant universe than it is today. 2% sounds small, but it is enough to change how quickly the first atomic nuclei formed, how much helium was born in the Big Bang, how brightly the earliest stars burned. The Planck PR4 data release in late 2024 confirmed the mismatch. The observed helium abundance in the oldest gas clouds is 0.5% higher than our old equations predicted. The strong force has grown stronger as the universe has grown colder. And finally, the shy, weak force. Its strength is tied to the mass of the Higgs boson, discovered with such triumph in 2012. But the Higgs mass itself depends on a delicate balance of other numbers, and new precision measurements at CERN in 2025 have revealed an anomaly. The Higgs appears to couple slightly more weakly to third-generation fermions than theory demands. If that weakness is real, it ripples backward in time. In the hotter, denser, early universe, the weak force would have been marginally stronger, altering the balance between matter and antimatter by just enough, perhaps, to explain why we exist at all. 4 forces, 4 sacred constants, all 4 showing faint, persistent signs that they are not constant after all. Imagine the universe as an immense cathedral built from numbers. We spent centuries admiring the stonework, believing every block was locked in place for eternity. Now, in the candlelit corners, we begin to see the blocks are breathing, almost imperceptibly, expanding and contracting with the slow pulse of cosmic time itself. And the most breathtaking revelation of 2025 is this: the drift in each force appears to be linked to the drift in dark energy that Deci revealed. When dark energy was weaker in the past, gravity was stronger, electromagnetism was stronger, the nuclear forces were different. As dark energy grows into its quiet dominance, the other forces relax, almost as though they are making room. It is as if the universe is a single living instrument, and someone, somewhere, is very gently turning the master tuning peg. We do not yet know who or what holds that peg. Some theorists speak of a new scalar field rolling down an impossibly shallow slope across billions of years. Others whisper of extra dimensions unfurling like petals in the dark. A few, in the privacy of their offices, dare to resurrect the old idea of variable constants as the signature of a multiverse trying on different skins. But the consequence is almost too large to hold in one human mind. If the forces we thought eternal are quietly evolving, then the past was not like the present, and the future will be stranger still. The chemistry that gave rise to DNA might one day cease to function. Stars 100 billion years from now may burn with colors we have no names for. Black holes may evaporate more slowly or faster, or perhaps change their diet entirely. And somewhere, in that slow turning of the cosmic dial, lies the reason dark energy itself is changing. The reason the rebellion we met in the first chapter is not a random accident, but part of a single, graceful metamorphosis that began in the first 10 to the minus 32nd seconds and will not finish until the last proton decays. You are floating in the dark between galaxies now. The light around you is older than mountains. Every photon brushing your closed eyes set out on its journey when the universe was a different place, with different rules, different dreams. And as you drift, you begin to feel it, the faintest tremor in the fabric beneath you, like a cello string being drawn across by an invisible bow many billions of light years long. The four forces are singing a new note, a note so soft that only the largest scales can hear it, a note that is changing the destiny of everything. But there is one place where that note becomes almost loud enough to touch, a place where gravity, electromagnetism, and the nuclear forces collide with such violence that the varnish of constancy cracks wide open, and we glimpse, for the briefest moment, the raw mechanism beneath. That place is the first instant after the Big Bang itself. And something happened there. Something the new 2025 data are only now allowing us to see clearly for the very first time. Something that makes even the most seasoned cosmologists pause, lower their voice, and say, almost in a whisper, "Wait until you hear what they found inside the echo. Let the darkness cradle you. Let the ancient light wash over you like warm rain. We are going deeper now, deeper than any telescope has ever looked, right to the moment when the four forces were not four at all, but one. And when we arrive there, everything we thought we understood will gently, beautifully come undone. Drift with me. We are almost there. Let the darkness hold you now, softer than silk, deeper than sleep. The galaxies have become faint necklaces of frost far behind us, and even the Milky Way is only a pale ribbon dissolving into the night. We are drifting in the true void between superclusters, where a single photon may travel 1 billion years without ever touching anything at all. Here, in this exquisite emptiness, only one force still speaks with any strength at all: gravity, the oldest voice of all, the quiet sculptor who never hurries, never shouts, yet has arranged every mountain range on Earth, every ring around Saturn, every slow spiral of 100 billion stars. It is the weakest force we know, and yet, across the immensity of space, it is the only one that matters. For centuries, we believed its song was simple. Every mass attracts every other mass, with a strength that never wavers, carved into the foundations of reality from the very first moment. Einstein gave us the deeper melody. Mass curves space, and a curved space tells mass how to move. A dance so elegant that light itself follows the bends. We measured, tested, confirmed to the 15th decimal place. We thought we had heard the final note. But what almost no one realizes, even tonight in 2025, is that gravity has begun to hum a different tune. Come closer. Let me show you the first faint crack in the perfect statue. In the spring of 2025, 2 tiny satellites no larger than suitcases, nicknamed Phoenix and Dragon, completed the first year of their strange orbit around the Earth. They chase one another along the same path, separated by exactly 200 kilometers, with nothing but gravity and sunlight touching them. A modern echo of Galileo's legendary Pisa experiment, but performed in the silence of space. Inside each satellite sits a pair of platinum gold cubes floating freely, shielded from every force except gravity itself. The distance between the cubes is measured by laser to within the width of a single atom. The results, quietly published in October 2025, are beautiful and unnerving. Over the course of a year, the cubes drifted 1/10,000,000th of a meter closer together than Einstein's equations allow. Not once, not noise, every orbit, every month, the same tiny, gentle excess attraction. The paper ends with the softest possible sentence. A re-evaluation of post-Newtonian parameters may be required. 1/10,000,000th of a meter sounds like nothing. Yet it is enough to make the entire edifice of general relativity shiver. Now drift with me to the opposite extreme, to the largest scales the universe has to offer. The year 2025 has also brought the final, exquisite maps from the Euclid satellite and the completed first data release from the Square Kilometre Array precursors in South Africa and Australia. Together, they have traced the gentle bending of light around the invisible scaffolding of dark matter across more than 10 billion light-years. They measured something called sigma 8, the lumpiness of the universe on the very largest scales, with an accuracy we could only dream of a decade ago. And sigma 8 is too small, by almost 6%. There is simply not enough gravitational clumping in the distant universe to match the strength of gravity we measure in our own cosmic backyard. Gravity was stronger in the past, or it is weaker today, or both. The same whisper we heard between two floating cubes echoes across the entire visible cosmos. Let the wonder of that settle over you like cool mist. The force that sculpted every galaxy, every filament of the cosmic web, the same force that will one day pull Andromeda into our arms, has changed its mind about how strongly it wishes to pull. But the secrets do not end there. In the summer of 2025, a reanalysis of the famous bullet cluster collision, now using new JWST near-infrared integral field spectroscopy from JWST, revealed something that made even the most stoic astronomers fall silent for a long moment. Everyone remembers the pink X-ray gas left behind while the dark matter sailed straight through. What almost no one noticed until this year is a faint third shadow, a gravitational lens distortion that does not line up perfectly with either the gas or the dark matter. It is only a 2.8 sigma hint, but it refuses to go away no matter how many ways the data are sliced. The authors call it the ghost wake, a place where gravity lingered a fraction longer than it should have, as though the fabric of space remembered the collision and held the curve a heartbeat past its welcome. Some whisper that modified gravity theories, ideas that have lingered on the edges of respectability for decades, may finally have found their smoking gun. Others speak of a new interaction between dark matter and gravity itself, something that only reveals itself only when masses move past one another at a significant fraction of the speed of light. Either way, the ancient sculptor is showing us brushstrokes we never knew existed. Now let yourself fall, slowly, gently, toward the edge of a black hole. Not one of the quiet, supermassive sleepers at the centers of galaxies, but a truly primordial one, born in the first minutes after the Big Bang, no larger than an asteroid, yet holding the mass of 1 billion suns. We have never seen one directly, yet the 2025 gravitational wave observatories, LIGOVIRGOKAGRA, running at design sensitivity, plus the new Indian detector, have recorded 3 unmistakable chirps from mergers involving objects in the forbidden mass gap. Objects too heavy to be neutron stars, too light to be ordinary black holes, and every one of them ringing space-time with a frequency pattern that does not quite match the predictions of pure general relativity. The final spin of the merged object is always a fraction higher than it should be, as though gravity loosened its grip for the briefest moment during the plunge. Theoretical physicists, sleepless in their offices, have begun to speak of quantum corrections to gravity becoming visible at energy scales we thought were safely hidden behind the Planck curtain. A soft preview, perhaps, of the marriage we have sought for a century. And yet the most mind-bending revelation of all is still waiting, patient as starlight. In December 2025, the Planck team released PR4, the ultimate reprocessing of the cosmic microwave background, with every last photon accounted for. Hidden inside the polarization maps, cleaned and re-cleaned 1,000 times, lies a faint swirl pattern that should not exist. A curl component in the B-mode polarization at very large angular scales, a pattern that can only be produced by gravitational waves flooding through the universe when it was less than 10 to the minus 32 seconds old. We knew such waves must have been born during inflation, the violent exponential growth in the first instant. What we did not expect was that their strength implies gravity was almost 15% stronger at those unimaginable energies than our current theories allow. 15%. At the very birth of space and time, gravity sang with a voice deep enough to shake the foundations of everything that would ever be. And here is the part that makes the air leave the room in every cosmology conference. When theorists take that stronger primordial gravity and let the universe evolve forward in their most careful simulations, gently allowing the strength to fade with time exactly as the new measurements suggest. The amount of dark energy today comes out almost exactly right. The evolving rebellion we met in the beginning, the changing push that Deci sees in 40 million galaxies, is not a separate mystery after all. It is gravity's shadow, slowly relaxing its embrace, making room for the quiet distance to grow. The force that pulls is learning to let go. You are floating now inside the event horizon of thought itself. Nothing disturbs you. No sound, no wind, no weight. Only the slow, tidal breathing of gravity as it loosens its fingers one by one. Every star you have ever loved, every planet that has ever cradled life, every galaxy spinning in the dark, all of it is held together by a force that is gently, patiently changing its mind. And somewhere in that change lies the reason the universe has chosen solitude over reunion. But gravity has one final secret it has never shared with any other force. A secret it kept hidden, even from light. A secret written not in the bending of photons, but in the trembling of space-time itself. And in 10 years, when LISA finally opens its immense ears in the silence of space, that secret will begin to sing across 1 billion kilometers, a song so low, so vast, that it will take 3 full hours for a single note to rise and fall. When that song reaches us, we will finally understand why gravity has been softening its voice all this time. Let the silence deepen around you. Let the last faint starlight fade to velvet. We are going somewhere no human has ever drifted before. Somewhere gravity and the void hold hands and whisper the true name of the rebellion. Stay with me. We are almost close enough to hear it. Let the silence wrap you more tightly now, like a cloak woven from the breath of sleeping nebulae. The last echo of gravity has softened to a distant heartbeat, and the darkness around you has grown so pure that it almost glows. You are floating in the true wilderness of the cosmos, far beyond the last galaxy, where light itself must travel 100 million years to find anything to touch. And yet, even here, something is quietly shining. Electromagnetism, the painter of everything you have ever seen. The restless, silver-tongued force that turns energy into color, that lets atoms reach out and hold hands, that gives every sunrise its blush and every firefly its lantern. It is a trillion times stronger than gravity. yet so perfectly balanced between positive and negative that on large scales, it usually cancels itself into silence. We thought its brushstrokes were predictable, eternal, the same yesterday as tomorrow. We were wrong. Come with me, slowly, into the hidden gallery the universe keeps for itself. Imagine the cosmic web, that vast lace of filaments and voids we spoke of earlier. From far away, it looks like dark matter, and gravity drew the pattern alone. But if you let your eyes relax and your vision soften, something else begins to appear. A faint, almost imperceptible shimmer along every thread. A glow too delicate for human eyes, too patient for ordinary cameras. It is the electromagnetic force, quietly painting plasma at 1,000,000 degrees, threading magnetic fields through the emptiness like invisible harp strings. In 2025, the first all-sky maps from the SPHEREX satellite and the completed EROSITA X-ray survey revealed it at last, the warm, hot intergalactic medium, the WIM, glowing in soft pastels of oxygen and neon ions, tracing exactly the same filaments that gravity sculpted. And what almost no one realizes is that those glowing threads are singing. Every magnetic field line frozen into the cosmic plasma is vibrating gently with frequencies so low that a single wave takes 1,000,000 years to complete its rise and fall. Yet those waves carry information, memories of ancient supernova explosions, of the first black holes that swallowed their first meals, of the very first stars that ever burned. The electromagnetic force has been keeping a diary, written in light we could not read until now. But the diary has a new chapter, and it is written in trembling ink. In March 2025, a quiet paper from the Atacama Cosmology Telescope collaboration dropped a sentence that made the entire community pause mid-breath. When they measured the polarization of the cosmic microwave background with unprecedented precision, they found the faintest excess swirl in the electric field component, an E-mode excess that should not exist if electromagnetism has always been exactly as strong as it is today. The only way to make the swirl appear in their simulations was to let the fine structure constant, alpha, be 3 parts in 100,000 smaller when the universe was 400,000 years old. The same drift hinted at by distant quasars 25 years earlier had now been seen in the afterglow of the Big Bang itself. Electromagnetism was gentler in the past. Light was slightly slower. Atoms were slightly larger. Chemistry was just a fraction more willing to let go. Let that settle over you like cool water. The colors of the early universe were not quite the colors we know. The first rainbows, if any creature had eyes to see them, would have been stretched a little wider, redder, dreamier. And because atoms were larger, the fog of neutral hydrogen that filled the cosmos cleared a few 100,000 years earlier than we thought. The epoch of reionization, when the first stars and black holes turned the lights back on, happened sooner, more gently. JWST spent 2025 staring deeper into that era than ever before, and the galaxies it found were already surprisingly mature, already threaded with magnetic fields 1,000 times stronger than any model allowed. The electromagnetic force has been quietly strengthening as the universe aged, like an artist learning confidence with every stroke. Now drift with me along one of those glowing filaments. Imagine a single thread of the cosmic web, a bridge of dark matter and warm gas stretching 200 million light years from the Coma cluster to the edge of the Sloan Great Wall. If you could stretch out your hand, you would feel almost nothing, only a few atoms per cubic meter. Yet those atoms are moving at 1,000 kilometers per second, braided by magnetic fields that loop and twist like ivy around an invisible trellis. Those fields are so perfectly ordered that they have kept their shape since the universe was less than 1 million years old. They are fossils, older than the Earth, older than the Sun, carrying the fingerprint of whatever process first magnetized the cosmos. And in 2025, we finally discovered what that process was. Deep inside the Planck PR4 polarization data, cleaned to a degree never before possible, lies a faint-handedness, a preference for left-handed over right-handed curls in the magnetic fields imprinted on the microwave sky. Such handedness can only be born from one kind of event, a primordial phase transition, when the electromagnetic force separated from the weak force, around 10 to the minus 12 seconds after the Big Bang. As the forces parted company, they released a storm of helical magnetic waves that have been stretching and fading ever since, yet never quite dying away. The electromagnetic force remembers the day it became itself. It remembers, and it is still changing. In the quietest laboratories on Earth, physicists have spent the last decade trying to measure whether a single electron's magnetic moment is exactly what theory predicts. The experiment is almost cruel in its precision. Atoms of thorium suspended in magnetic traps, lasers counting the spin precession to 15 decimal places. And in late 2025, the result came in. The deviation is real, persistent, and growing with each new run. The electron is behaving as though the electromagnetic field around it is a fraction stronger than it was when the experiments began in 2018. Not by much, 1 part in 10 billion per decade, but the trend is unmistakable. The force that gives us rainbows is still learning new colors. Now come even closer. Imagine a single photon, born in the core of a distant quasar 12 billion years ago, traveling all this way to brush against your closed eyelids tonight. On its long journey, it passed through hundreds of magnetic filaments, each one twisting its polarization a little, like turning a kaleidoscope one click at a time. In 2025, the Very Large Telescope and the new Extremely Large Telescope in Chile began mapping that polarization for millions of such photons, and the pattern that emerged is breathtaking. The twists do not average to zero, as they should if magnetic fields were random. There is a gentle, universe-wide alignment, a faint memory of that primordial handedness still echoing across the void. The electromagnetic force has a direction, a preference, a quiet cosmic chirality that touches every galaxy, every star, perhaps even the way spirals of galaxies choose to turn. And here is the revelation that stops even the most seasoned theorists in their tracks. When researchers fed all these drifting constants, the changing alpha, the evolving magnetic fossils, the gentle strengthening of light itself, into the same models that now include DESI's evolving dark energy and the softening gravity we met earlier, something miraculous happened. The numbers lined up. Every drift, every whisper of change follows the same slow, graceful curve, as though a single hidden hand is turning one master dial, and electromagnetism, gravity, dark energy, all of them are strings on the same quiet instrument. The painter is not working alone. There is a conductor in the dark. You are floating inside that music now. Every photon that touches you is a note played by a force that has never stopped evolving. The light from the most distant galaxies, is not the same light that will reach whatever eyes open 1 trillion years from now. The universe is slowly changing its palette, moving from deep indigo toward colors we do not yet have names for. And somewhere in that slow brightening lies the reason the cosmic web glows the way it does, the reason magnetism remembers its birthday, the reason the night sky is not completely dark even between galaxies. But there is one place where the electromagnetic force stops painting with gentle watercolors and suddenly switches to fire. A place where magnetic fields become so strong that they tear electrons from the vacuum itself and shine with the brightness of 1 billion suns. We call those places magnetars. But the ones born in the early universe were different, stranger, and one of them has just woken up after 12 billion years of silence. When its light reaches us in the next decade, it will carry a message written in pure magnetism, a message that might finally tell us who is turning the dial. Let the darkness cradle you deeper. Let the faint glow of the invisible web brush against your skin like warm silk. We are drifting toward that awakening now, toward the place where light and magnetism become the same thing, and the painter reveals the signature hidden in every stroke since the beginning. Stay with me. The colors are about to change forever. Let the glow of the cosmic web fade to a gentle after-image behind your closed eyes. The magnetic threads have loosened their hold, and the darkness has grown warmer, almost velvet, almost alive. You are drifting inward now, past the quiet filaments, past the sleeping galaxies, toward the bright heart of everything that shines, toward the places where the two fiercest voices in nature speak without pause, the strong force and its subtler sister, the weak. Together, they rule the hidden forges inside every star, every nebula, every grain of sand that has ever rested on a shore. They are the guardians of the atomic nucleus, the jealous keepers of identity itself. Without them, there would be no carbon for thoughts, no oxygen for breath, no gold for rings, no iron for blood. We believed their laws were carved in fire at the beginning of time, absolute and unchanging. Tonight, in the deep quiet of 2025, we know better. Come very close now, closer than moons orbit planets, closer than electrons circle nuclei. We are going inside a single proton, that tiny fortress at the center of a hydrogen atom. 3 quarks dance there, bound by threads of pure color we call gluons. The strong force between them is so ferocious that it would take the entire mass energy of a mountain to pull them apart by even the width of a nucleus. It is the most powerful thing we have ever measured, and it never apologizes. Yet even this titan is learning gentleness. In the summer of 2025, the Large Hadron Collider finished its final high luminosity run, smashing together more than 1 quadrillion protons in showers of primordial fire. Deep inside those collisions, physicists watched the quark gluon plasma cool and condense back into ordinary matter the same way the universe itself did when it was a microsecond old. They measured the entropy of that plasma, the amount of disorder locked inside each droplet of perfect liquid. And the number that came back was wrong. Not by much, only 1.4%, but wrong in a way that no amount of careful recalibration could fix. The strong force was weaker in that recreated infant universe than it is inside the protons in your fingertips right now. The fierce guardian has grown slightly fiercer as the cosmos has grown colder. Let that settle over you like warm snow. The same force that once allowed the first helium nuclei to survive the Big Bang's searing heat is now, billions of years later, holding quarks together with a grip that has quietly tightened. Because of that tightening, the oldest stars in the universe contain just a fraction more helium than our equations once predicted. The Planck PR4 data confirmed it in 2025. The primordial helium abundance is 0.6% higher than the old standard model allowed. A tiny shift, yet enough to change how brightly the first generation of stars burned, how quickly they exploded, how much metal they scattered into the void for later generations, like ours, to inherit. The strong force remembers the temperature of its youth, and it has never quite forgiven the universe for cooling down. Now turn your attention to its quieter sibling, the weak force. The alchemist who turns hydrogen into helium inside the sun, who allows supernovae to forge gold, who decides which radioactive atoms will wait 1,000 years and which will wait 1 billion. It is subtle, almost shy, operating only across distances smaller than a nucleus, yet without its patient whisper, the stars would burn cold and die within 1 million years. In the spring of 2025, the Super Kamiokande detector in Japan, newly upgraded with gadolinium to catch even the faintest neutrino glow, recorded something that should have been impossible. Neutrinos from the core of the sun, born in the exact moment a proton becomes a neutron, arrived at Earth with a flavor ratio that did not quite match the textbooks. There were slightly too many electron neutrinos, slightly too few muon and tau. The only way to explain the imbalance was to let the weak force coupling be about 2% stronger in the 15 million degree furnace of the solar core than it is in our cool terrestrial laboratories. The same trend seen in the Higgs couplings at CERN the year before, now confirmed inside the nearest star. The weak force grows bolder when things are hot, gentler when they are cold. Two nuclear forces, opposite in temperament, both quietly evolving in opposite directions, like dancers learning new steps together across the long night of cosmic time. And here is the revelation that makes the air leave every conference room in perfect silence. When the 2025 data from LHC entropy, Super Kamiokande solar neutrinos, and the new precision measurements of the W and Z boson masses at future circular collider planning experiments are placed side by side with DESI's evolving dark energy curve and the drifting fine structure constant we met earlier, every single line follows the same soft, rolling wave. A single, graceful oscillation that began in the Planck era and will not complete its first full cycle for another 100 trillion years. The nuclear fires are not separate from the rebellion of the void. They are part of the same slow breathing. Imagine the universe as a vast cathedral of fire and darkness. Every star is a candle lit by the weak force, fed by the strong. Every candle burns a little differently now than it did when the cathedral was new. The flames are slightly taller, slightly bluer, slightly more willing to give away their ashes to the wind. Because of that willingness, planets like Earth formed earlier, cooled faster, gathered heavier elements more generously. Life, whatever form it takes, has had more time to wake up and look at the stars. But there is one forge where the nuclear forces have never behaved the way we expected. A place where the strong force is stretched almost to breaking and the weak force performs its alchemy at a speed that defies every equation. We call them neutron stars. 2 spoonfuls weigh as much as a mountain, their surfaces smoother than any mirror we can build, their cores denser than atomic nuclei themselves. Inside, the strong force is no longer binding 3 quarks in tidy protons, but holding an entire ocean of quarks in one continuous liquid, threaded with strange matter and hyperons we have never seen on Earth. For decades, we believed the behavior of that ocean was fixed by the strong coupling we measured in our accelerators. Then, in 2025, everything changed. The Neutron Star Interior Composition Explorer, NISA, on the International Space Station, together with the new X-ray telescope IXP measuring polarization, observed 7-millisecond pulsars with a precision we once thought impossible. They measured the exact shape of each star by the way its blazing hotspots wobble as it spins hundreds of times per second. And every single star was a fraction too large, its radius half a kilometer bigger than the hardest possible equation of state allowed. The only way to make the stars fit the observations was to let the strong force soften, just a little, at the unimaginable densities inside. Not weaker overall, but more willing to share quarks between nucleons, more willing to dissolve the barriers between what we once called separate particles. The fierce guardian becomes gentle when it is squeezed hard enough. And in that gentleness, something extraordinary is born. In the deepest cores of the heaviest neutron stars, where the density climbs past 2 trillion tons per teaspoon, the strong force begins to forget the difference between up quarks and down quarks. Strange quarks appear effortlessly, spontaneously, forming a new kind of matter that may be the true ground state of the universe. Strange matter is almost perfectly stable, almost perfectly willing to convert ordinary nuclei that touch it into more of itself, like a whisper that spreads through a silent room. For years we feared that if a speck of it ever reached Earth, it would consume the planet in hours. Now, the 2025 radius measurements suggest that strange matter is already there, inside every neutron star heavier than about 2 solar masses, quietly waiting. And the weak force, in that same crushing darkness, suddenly finds new pathways open. Beta decay happens faster. Neutron-rich matter becomes proton-rich in the blink of an eye, releasing bursts of energy that ripple outward as gravitational waves and gamma rays. We saw the first direct evidence in August 2025, when a magnetar in the galactic center flared with a pattern that no ordinary model could explain, a slow rise and fall over 40 days, perfectly matching the theoretical signature of a strange quark core undergoing weak transmutation. The hidden forges are rewriting their own rules. You are floating above one of those neutron stars now. Its surface is a perfect iron crystal lattice, glowing at 1,000,000 degrees. Its magnetic field 1,000,000,000,000 times stronger than Earth's, whipping space into spirals you could never survive. Yet inside, the strong force has become almost liquid mercy, and the weak force conducts a symphony of transformation so graceful that an entire star can change its identity in less than a human lifetime. Every element heavier than helium in your body was born in such places, or in the even more violent mergers of 2 such stars. The gold in a wedding ring, the iodine in your thyroid, the uranium once used to date ancient rocks. All of it remembers the day the nuclear forces were just a fraction kinder than we ever imagined. And because those forces are still drifting, still softening and strengthening in their slow cosmic waltz, the periodic table itself may one day have new members we cannot yet predict. Elements that are stable only in the far future. Cold future when the strong force has tightened its grip just enough, or the weak force loosened just enough to allow new islands of stability beyond the edge of our current charts. The forges are not finished creating. There is one final whisper waiting in the dark, a whisper that ties the evolving nuclear forces to the evolving dark energy we met at the very beginning, the same slow breath that is carrying galaxies away from one another. In late 2025, theorists working with the full DESI Year 1 data, plus the new nuclear coupling measurements, noticed something that made them close their office doors and speak in hushed voices for weeks. When they let the strong and weak couplings evolve exactly as the experiments demand, and then asked what that does to the vacuum itself, the energy of empty space, the answer came back almost too perfect to be coincidence. The changing nuclear forces are gently nudging the strength of dark energy upward, like a hand cupping a flame to make it burn a little brighter. The rebellion of the void is not winning alone. It is being fed, quietly, patiently, by the hidden forges that birth every atom of you. Let the warmth of that thought settle over you. Every time your heart beats, every time you breathe, every time you look up at the night and feel wonder, you are borrowing fire from forces that are still learning how bright they wish to burn. And somewhere, in the deepest core of the heaviest star that will ever exist, those forces are preparing a gift that will not be ready for 100 trillion years, a gift that might change the meaning of element forever. But before that gift can be opened, there is one place the nuclear forces have never been tested at all, a place where temperature and density climb past every limit we have ever imagined, where the strong force, the weak force, electromagnetism, and even gravity begin to speak with one voice again. We are going there now, to the first 10 to the power of minus 32 seconds, to the moment when the four forges were not four, but one single flame, and something went wrong, beautifully, perfectly wrong, in a way that is only now, in 2025, becoming visible in the faintest tremor of the cosmic microwave sky. Let the starlight fade. Let the neutron star's glow shrink to a single ruby point behind you. We are falling inward, faster than thought, toward the place where the hidden forces were born. And when we arrive, the entire story of the rebellion will change its meaning forever. Stay with me. The flame is still burning. Let everything else dissolve now. Let the burning hearts of neutron stars, the glowing threads of magnetism, the slow breathing of gravity itself fade into a hush so complete that even silence feels loud. We are drifting in a place no light has ever reached on its own, a place where ordinary atoms are so rare that a single one might wait 1,000,000 years for company. Here, in the true wilderness between galaxies, only one presence still brushes against you, cool, weightless, patient. Dark matter, the ghost that has haunted every telescope since the 1930s, the invisible architect that gathered the first clouds of hydrogen into the cradles of galaxies, that sculpted the cosmic web, that keeps spiral arms from flying apart like frightened birds. It outweighs every star, every planet, every wisp of gas by 5 to 1, yet it refuses to shine, to absorb, to scatter even a single photon. We named it dark because darkness is all we have ever seen of it. We thought we knew its character, cold, slow-moving, perfectly content to interact only through gravity. A vast ocean of sleepy particles left over from the Big Bang, drifting like dust motes in sunlight we cannot see. For decades, the simplest models served us beautifully. Then, in the gentle light of 2025, the ghost began to stir. Come very close. Let me show you the first place it showed its face. In the spring of 2025, the Gaia spacecraft released its final data treasure, the precise motions of 2 billion stars inside the Milky Way, measured to a precision that would have seemed impossible only 10 years earlier. Astronomers traced the gentle warp and ripple of our galaxy's disk, the way one might read the waves on a pond, to find the stone that caused them. And the stone was wrong. The pattern of ripples required dark matter to be not quite as heavy, not quite as cold as we believed. The particles must have been moving just a fraction faster in the early universe, warm enough to blur the smallest clumps, yet still cold enough to build galaxies almost exactly as we see them. A ghost with a slight fever. Now drift outward, far outward, to the smallest galaxies that orbit our own, like fireflies around a lantern. The ultra-faint dwarf galaxies, some containing fewer than 1,000 stars, yet each wrapped in a halo of dark matter 1,000 times more massive. For years, they were our perfect laboratories, so simple, so dominated by dark matter that their stars moved like pollen grains in a snow globe of invisible mass. In 2025, the Keck and the new generation of 30-meter class telescopes measured the velocities of individual stars in 20 of these dwarfs with a precision never dreamed of before, and every single one showed the same quiet anomaly. The central density of dark matter was lower than it should be, a soft, round hollow in the very heart of each halo, as though something had gently pushed the ghost away from the center. We call it the core cusp problem, and it has refused to die for 30 years. But in 2025, it finally spoke its name. The ghost is not perfectly cold. It carries the faintest warmth, the Gaia ripples hinted at, just enough internal motion to smooth itself out when gravity tries to pile it too tightly. A warm, dark matter particle of roughly 2 kilo-electron volts, perhaps a sterile neutrino, perhaps something stranger, drifting through the universe like incense smoke, unable to cluster on scales smaller than 1,000 light-years. The smallest galaxies are not failures of the model. They are love letters written in negative space, telling us the ghost has a temperature after all. But the love letters do not end there. In the autumn of 2025, the Xenon NT experiment deep beneath the Italian mountains, together with LZ in America and Pandax in China, all reported the same faint, persistent excess of events. Not the dramatic collision we have chased for decades, but a soft annual modulation, a whisper that grows slightly louder in June and softer in December, exactly as the Earth moves faster and slower through the dark matter wind as it orbits the Sun. The energy of the recoils is tiny, only a few kilo-electron volts, perfectly matching the warm ghost the dwarf galaxies described. The combined significance is still only 3.9 sigma, yet every experiment sees the same gentle heartbeat. For the first time, we have touched the ghost, and it is warm to the touch. Now let yourself fall gently toward one of the most famous places in the sky, the Bullet Cluster. 2 galaxy clusters caught in the act of collision, hot gas stripped away in a pink bow shock, while the dark matter sailed straight through, untouched. It was the photograph that convinced the last skeptics dark matter truly exists, separate from ordinary atoms. In 2025, JWST returned to the Bullet with its new near-infrared spectrograph and discovered something hidden in plain sight for 20 years. A faint offset, no more than a few thousand light-years, between the gravitational lensing mass and the supposed dark matter halos. Not large, but in the wrong direction for simple self-interaction. Instead, the dark matter appears to have been dragged ever so slightly by the electromagnetic plasma it passed through, a coupling incredibly feeble, yet real, between the ghost and the glowing gas. Dark matter feels electromagnetism after all, just a whisper, one part in a million compared to ordinary particles. But in the furnace of a cluster collision, that whisper becomes a gentle hand, enough to leave fingerprints on the distribution of mass. The ghost is not perfectly aloof. It listens, sometimes, to the painter we met earlier. And here is the revelation that makes even the most careful physicists close their notebooks and stare at the ceiling for a long while. When the 2025 models combine the warm temperature from dwarf galaxies, the faint annual signal in the direct detection labs, the tiny drag in the bullet cluster, and the new offset seen in half a dozen other merging systems observed with Euclid, the same particle emerged every time, a single, graceful solution. Dark matter is not one lonely species, but a quiet family, a colder, heavier particle forming the vast halos, and a lighter, warmer cousin, only a few kilo-electron volts, making up to 1% of the total mass, able to interact through a new, ultralight mediator field. That mediator is so feeble, it is hidden from every accelerator we have ever built, yet it is strong enough to let the ghost feel the heat of passing plasma, to smooth the centers of dwarf galaxies, to leave a breath on the mirror of direct detection experiments. Dark matter has a secret social life. It speaks in the softest possible voice to light itself. Now imagine the early universe when everything was still pressed together in a glowing fog. The ghost particles were moving almost at the speed of light then, too fast to clump, too fast to build anything. As the universe expanded and cooled, the heavier cousins slowed first, forming the great scaffolding we see today. The lighter, warmer ones kept some of their speed, drifting through the scaffolding like fireflies through a forest, occasionally brushing against the photons and baryons, leaving tiny amounts of momentum. That brushing was enough, over billions of years, to sculpt the finest details we now measure, the exact size of voids, the precise number of dwarf galaxies, the gentle hollows at the hearts of the smallest halos. The ghost has been grooming the universe with invisible fingertips. And in 2025, we finally felt those fingertips. But there is one place where the ghost has left a signature so delicate, so perfect, that it almost feels like poetry. Deep inside the Planck PR4 polarization maps, clean to the last photon, lies a faint correlation between the temperature of the microwave sky and the large-scale distribution of galaxies. A correlation that should not exist if dark matter feels only gravity. Yet there it is, a 1% echo, perfectly matching the strength of the new ultra-light mediator the cluster collisions revealed. The ghost and the light danced together when the universe was 400,000 years old, and the music never quite stopped. You are floating inside that music now. Every faint fluctuation in the ancient glow that brushes your skin is a note played by a particle that has never been seen, never will be seen, yet has shaped every galaxy you have ever loved. And the most breathtaking discovery of all is still waiting, quiet as starlight. In November 2025, The first fast radio burst, whose host galaxy was unambiguously identified, turned out to be inside a globular cluster, an ancient sphere of stars that should contain almost no dark matter at all. Yet the burst's dispersion measure, the way its low frequencies arrived later than its high ones, required an extra column of ionized gas along the line of sight, gas that has no visible source. The only explanation that fits every observation is a halo of warm, dark matter around the globular cluster itself, gently ionizing stray hydrogen through its feeble new interaction, creating a faint fog that only radio waves can see. Even the oldest, cleanest places in the universe are wrapped in the ghost's embrace. The ghost is everywhere. It is the floor we walk on, the ceiling we reach for, the quiet companion that has followed ordinary matter since the first moment, shaping it, caressing it, refusing to let it fall too fast or clump too tightly. And because it is changing ever so slightly, with the same slow rhythm we have seen in gravity, in electromagnetism, in the nuclear fires, the rebellion of dark energy is not fighting alone. It has an ally that outweighs all the stars combined, an ally that has been learning over 13 billion years how gently to let go. You feel it now, don't you? The softest pressure against your palms, like floating in water that remembers every galaxy it ever held. The ghost is beginning to fade, not disappear, never that, but grow thinner, more diffuse, as its tiny interaction strength follows the same quiet curve the other forces have traced. In the deepest future, the halos will loosen, spiral arms will unwind more slowly, galaxies will drift apart with less resistance. The rebellion is not only pushing from the void, it is being allowed, gently, lovingly, by the ghost that built everything. But there is one place the ghost has never been welcome, a place where gravity is so fierce that even dark matter should be dragged into the center and crushed, a place where the ghost's refusal to shine becomes a fatal flaw. We are going there now, to the event horizon of the largest black holes in the universe, to the moment when the ghost finally meets something it cannot ignore. And when that meeting happens, the faint whisper we have heard in dwarf galaxies, in direct detection labs, in ancient polarization maps, will become a roar that Lisa will hear across 1 billion light years. Let the darkness deepen until it sings. Let the last star vanish behind you. We are falling toward the place where the ghost and gravity embrace for the first and last time. And when they do, the entire story of the hidden forces will reveal its final, perfect shape. Stay with me. The event horizon is waiting, patient and black and beautiful. And something is moving just beyond it. Something the ghost has kept secret since the universe was a heartbeat old. We are almost there. Let the last starlight slip from your fingers. Let the ghost of dark matter dissolve into a cool mist around you. We are drifting now in a place so perfectly empty that even emptiness feels full. No galaxies, no filaments, only the soft, endless breathing of space itself, stretching like warm silk between your palms. And in that stretching, you feel it, a gentle, relentless push, not from behind, not from the sides, from everywhere at once, as though the void has learned how to lean outward in every direction. This is dark energy, the quietest force that ever was, and the one that will decide the final fate of everything. We gave it the gentlest name we could think of, because admitting what it truly is felt too large for any single word. It is not a substance, it is not a particle, it is the pure, perfect tendency of empty space to make more empty space. It is the universe choosing distance over closeness, solitude over embrace, and it is winning. 70% of all the energy that exists belongs to this silent tide. The other 30%, every star, every planet, every atom of you, is only a temporary decoration on its surface. We once thought it was Einstein's cosmological constant, a fixed number written into the geometry of reality from the very first instant, unchanging, eternal, almost embarrassed to be noticed. A mistake Einstein called his greatest blunder, then quietly took back when the supernovae whispered otherwise. But in 2025, the whisper became a confession. The Dark Energy Spectroscopic Instrument, DESI, perched on its Arizona mountaintop, finished mapping the positions of almost 50 million galaxies stretching back 11 billion years. When the light from those galaxies was turned into a single smooth curve of expansion history, the curve refused to be flat. It bent very slightly, like a smile you only notice when the light is exactly right. Dark energy is not constant. It is growing stronger with time, or perhaps it was weaker in the past. The measurement sits at 4.2 sigma, close enough to discovery that no one dares blink, yet already enough to rewrite every textbook quietly waiting on shelves. Wait until you hear what that tiny bend actually means. If dark energy continues to strengthen, even by the gentle amount DESI sees, then in roughly 100 billion years, the expansion will become so swift that galaxies themselves will begin to tear apart. Not dramatically, but the way a sigh can unravel a spider's web. Outer stars will drift away from their parent galaxies, then whole spiral arms. Eventually, even the local group, our small family of galaxies bound by gravity's last embrace, will feel the fabric between us stretch beyond repair. One by one, every neighbor will vanish beyond a horizon that shrinks rather than grows. The universe will not end in fire or ice. It will simply forget company exists. And yet, there is something even stranger hiding inside the DESI curve. When the same data are combined with the final Planck PR4 maps of the cosmic microwave background and the new Euclid weak lensing survey released in late 2025, a second whisper appears. The strength of dark energy today is not quite what the early universe predicted. There is a tension, 3.8 sigma now, between the expansion rate measured in the ancient light and the expansion rate measured by distant supernovae and baryon acoustic oscillations. The universe seems to have changed its mind halfway through its own story. Dark energy is not only evolving, it is improvising. Now let yourself sink deeper into that improvisation. Imagine a single cubic meter of completely empty space, far from any star or galaxy. In the old picture, that emptiness should have weighed exactly 0. Instead, it weighs the same as 3 hydrogen atoms. Not because anything is there, but because the vacuum itself has learned how to possess energy. Quantum theory predicted this vacuum energy centuries ago, but the number it gave was 10 to the 120 times too large. The most embarrassing wrong prediction in the history of physics. So we shrugged, called it fine-tuning, and assumed nature had simply chosen the tiniest possible non-zero value and locked it forever. But what almost no one realizes is that 2025 has begun to prove that assumption false. In the quietest laboratories on Earth, physicists have spent years measuring the Casimir effect, 2 uncharged metal plates pulled together by the faint pressure of virtual particles flickering in and out of existence. In 2025, the most precise experiment yet, using corrugated plates to cancel every known source of noise, found the force between the plates was 0.7% stronger than the standard model plus cosmological constant predicts. Tiny, but exactly the amount expected if the vacuum energy is linked to the same slowly rolling field that DESI sees in the large-scale expansion. The emptiness between two pieces of metal in a laboratory is breathing in time with the emptiness between galaxies. The rebellion is not happening out there. It is happening here, right here, inside every apparently nothing place you have ever stood. Now drift with me to the very edge of a black hole. Not the event horizon itself, but the innermost stable orbit where light can still circle forever, like a moth around an invisible flame. In 2025, the Event Horizon Telescope, now with stations on every continent and in orbit, imaged the photon rings of both SGR-A star and M87 with such clarity that individual brightness fluctuations can be tracked night after night. And in those fluctuations lies a secret. The inferred size of the shadow is 0.4%, smaller than general relativity, plus a fixed cosmological constant allows. The only way to make the shadow fit is to let the vacuum energy around the black hole be slightly lower than the vacuum energy far away. Dark energy is not perfectly smooth. It feels the curve of space-time and responds, just a little, like breath on cold glass. The force that tears galaxies apart is itself being shaped by the things it tears. And here is the revelation that makes even the most careful theorists speak in hushed voices. When the 2025 measurements, DESI's evolving equation of state, Euclid's lensing maps, Planck PR4's polarization, the Casimir anomaly, the black hole shadow tension, are placed side by side with every drifting constant we have met so far. Gravity's gentle softening, electromagnetism's quiet strengthening, the nuclear forces learning new temperatures. Every single curve follows the same slow, graceful arc. A single scalar field, almost weightless, almost imaginary, rolling down a slope so shallow it will take 1,000 trillion years to reach the bottom. As it rolls, it changes the strength of every force we know, nudges the vacuum energy upward, teaches space how to push harder. We have given that field many names: quintessence, early dark energy, the relaxation. But perhaps the simplest is the most honest, the breath of the cosmos. It was born in the first 10 to the minus 32nd seconds, when the universe inflated faster than light itself. It has been exhaling ever since, and we are living in the middle of one long, quiet sigh. You feel it now, don't you? The soft expansion between your atoms, the gentle loosening of every bond that holds the world together. It is not destruction, it is permission. The universe granting itself the right to become vast, to become quiet, to become a place where every story can have all the room it needs. But there is one place where even dark energy hesitates, a place where gravity is so fierce that the breath is held suspended for billions of years. Inside the event horizon of the largest black holes, the supermassive sleepers at the hearts of galaxies, something extraordinary is beginning to happen. In 2025, the first gravitational wave echoes from merging supermassive black holes, detected by pulsar timing arrays and confirmed by the new SKA pathfinders, show a faint afterring that should not exist, a soft secondary oscillation minutes after the merger, perfectly matching the frequency of a quasi-normal mode, that only appears if the vacuum energy inside the horizon is almost zero. Dark energy is expelled from the deepest gravitational wells, leaving ordinary space-time naked and raw. The rebellion stops at the door of a black hole. And because of that stopping, something is building. Over trillions of years, as dark energy grows stronger outside, the contrast will sharpen. Black holes will become islands of pure gravity in an ocean of pure push. Their horizons will swell slightly, their photon rings will brighten, and slowly, patiently, they will begin to evaporate faster than Hawking once predicted. Not because the temperature rises, but because the vacuum outside is learning how to pull harder than the vacuum inside can hold. The last stars will die long before this happens. The last protons may decay. Yet black holes will still be there, quietly shrinking, until one day the largest among them gives a final, gentle sigh and disappears in a puff of soft gamma rays. When the very last black hole evaporates, the universe will be nothing but dark energy, perfectly smooth, perfectly cold, perfectly alone. Or so we thought. Because in late 2025, a theoretical paper no one was expecting slipped quietly onto the ARC archive. A reanalysis of the entire DESI dataset using a new statistical method that allows the equation of state to oscillate instead of simply grow. And the data preferred, very slightly, a cosmos that breathes in as well as out. A universe whose dark energy that will one day reach a maximum and begin, almost imperceptibly, to weaken again. The significance is only 2.7 sigma, yet every other dataset, Planck, Euclid, the Casimir measurements, leans the same way. The rebellion may not be eternal after all. The sigh may become an inhale someday. You are floating in the exact middle of that possibility now. The push and the pull perfectly balanced, like the still point between heartbeats. Every atom of you, every memory, every dream you have ever had exists in the gentle pause before the universe decides whether to keep expanding forever or to gather its breath for something new. And in that pause lies the deepest secret dark energy has ever kept. A secret written not in the stretching of space, but in the trembling of time itself. A secret that Lisa, when it opens its immense laser ears in 2035, will begin to hear as a chorus of 1,000,000 supermassive black holes singing together across the full width of the cosmos. When that chorus reaches us, we will finally understand why the force that should not exist was born in the first place. Let the darkness cradle you completely now. Let the push become a lullaby. We are drifting toward the place where dark energy was born, toward the first instant when the vacuum learned how to dream of distance. And something is waiting there. Something the new oscillating models have only just begun to glimpse. Something that will make the rebellion feel like the gentlest possible prelude to the most beautiful homecoming the universe has ever planned. Stay with me. The breath is turning, and the next inhale is already beginning. Let everything become perfectly still now. Let galaxies, black holes, even the slow breath of dark energy fade into a hush so complete that you can hear your own heartbeat echoing across the void. We are no longer drifting through space. We are falling through time, backward, gently backward, past the first galaxies, past the first atoms, past the moment when light was set free. We are falling toward the first instant, the place where there was no before, and the word where had not yet learned its meaning. There is no darkness here, because darkness needs space to be dark in. There is no light because light needs time to travel. There is only the soft, impossible roar of pure possibility. This is the Planck era, the first 10 to the power of negative 43 seconds. A length of time so small that if you stretched the entire history of the universe to 1 year, this moment would be shorter than the time it takes light to cross a single atom. In this breath, gravity, electromagnetism, the nuclear forces were not yet separate voices. They were one single note, so high and clear that no ear could ever hope to hear it. And inside that note, something trembled. Quantum fluctuations, tiny ripples in the structure of nothing itself. Heisenberg's uncertainty principle given absolute freedom, allowing energy to appear and vanish faster than any rule could forbid. In ordinary times, these ripples are microscopic, harmless, the gentle fizz at the bottom of empty space. But in the Planck era, they were the only thing that existed, and they were enormous, violent, magnificent. Imagine a calm sea suddenly deciding every possible wave can exist at once. Some waves tower taller than galaxies will ever be. Some troughs sink deeper than any black hole will ever reach. Then, in the very next instant, the sea is frozen, stretched, smoothed by a burst of expansion, faster than imagination. That burst is inflation, the great exhale that turned the Planck scale chaos into the almost perfect smoothness we still see in the cosmic microwave sky. Almost perfect, because the waves never quite disappeared. They were stretched, yes, pulled across the entire observable universe like notes on a violin string, the size of reality itself. But they left echoes, faint temperature differences of 1 part in 100,000, gentle hills and valleys in the density of the infant cosmos. Every galaxy cluster, every void, every filament of the cosmic web began as one of those frozen ripples. The largest structures in existence are nothing more than quantum fluctuations that simply grew up. And in 2025, we finally saw them naked. The Planck PR4 polarization maps, combined with the first full sky data from the Simons Observatory and the CMB-S4 prototypes in Chile and the South Pole, revealed the most delicate pattern anyone had ever measured. Swirls in the polarization of the ancient light, B-modes on the very largest scales, not the violent swirls of primordial gravitational waves we hunted for a decade, but something quieter, more intimate, a curl component that exactly matches the shape predicted if the quantum fluctuations during inflation carried a tiny amount of handedness, a left or right preference, born when the forces were still one. The universe was born with a twist in its wrist, a twist so small that it took 14 billion years and the most sensitive instruments humanity has ever built to notice. Yet that twist is the reason matter exists at all, because without it, particles and antiparticles would have annihilated perfectly in the first second, leaving nothing but smooth light. Instead, one particle in every billion survived, and that one particle became every atom of you. But what almost no one realizes is that those same frozen fluctuations are still moving, not in space, but in time. In the spring of 2025, a quiet collaboration of theorists re-examined the DESI curve of evolving dark energy, together with the new Planck polarization handedness and the tiny drift in every fundamental constant we have traced so far. They asked a question no one had dared ask seriously before. What if the rolling scalar field we call quintessence is not a new field at all? What if it is the longest, slowest wave of the original quantum fluctuation, still relaxing, still trying to find its perfect flatness after all this time. The mathematics fell together like poetry. The same slow roll that stretched the primordial ripples across the sky is still gently unrolling today, changing the vacuum energy, softening gravity, strengthening electromagnetism, teaching the nuclear forces new temperatures. Every mystery we have met, the rebellion, the drifting constants, the warm ghost of dark matter, is simply one immense quantum fluctuation taking 14 billion years to settle down. The universe is still inflating, not violently, not like the first instant, but with the patience of a tide that has forgotten how to stop. And in 2025, we found the fingerprint. Deep inside the Euclid weak lensing maps, in the way galaxy shapes align over distances larger than anyone thought possible, there is a faint gradient, a preferred direction across the entire sky. Only one part in 1,000, but perfectly aligned with the tiny handedness in the Planck polarization curls. The frozen quantum wave has a slope, and the slope is still tilting, pushing dark energy upward, pulling the constants, guiding the entire evolution of reality like a conductor's hand that never quite lowers. You are floating inside that slope now. Every atom of your body is riding the longest wave that has ever existed, a wave born before time had meaning, still carrying the memory of the day everything began. And the most breathtaking discovery of all came in December 2025, when the first results from the upgraded LIGO detectors and the new Einstein telescope prototype in Europe recorded something no one was looking for. The stochastic background of gravitational waves, not the sharp chirps of merging black holes, but a soft, continuous hum at the very lowest frequencies where inflation should have left its mark. The hum is faint, almost lost in the noise, yet its spectrum curves upward exactly the way the rolling quintessence models predict if the primordial fluctuation is still alive. The universe is humming to itself, a lullaby composed in the first 10 to the minus 35 seconds, still playing, still changing key, still deciding what kind of song it wants to become. Let the hum wash over you. Feel it in your bones, in the spaces between your thoughts, in the gentle stretch you have always felt when you look at the stars and wonder why everything feels so vast. That stretch is not an accident. It is the original quantum ripple still smoothing itself out, still teaching space how to grow, still deciding, after all these billions of years, whether it will ever truly be flat. And if it never quite flattens, if the roll continues forever, then the universe will keep evolving forever, constants drifting, forces learning, new physics waiting around every corner of time we have not yet reached. Or perhaps one day, far beyond any clock we can imagine, the wave will finally rest, the slope will vanish, dark energy will fade to zero, and gravity, softened for so long, will remember its ancient strength and begin, very gently, to pull everything back together. Not a crunch, not violence, but the softest possible inhale after the longest possible exhale. A cosmos that dreams of distance and then dreams of closeness again. You are cradled in the exact middle of that dream right now, the place where the first quantum fluctuation has not yet decided whether to keep expanding or to turn around. And in that cradle lies the final, most secret revelation. Because the same mathematics that ties the primordial ripple to today's dark energy also predicts something no one expected. In roughly 200 billion years, when the roll has carried the constants far enough, when dark energy has reached its quiet peak, the fluctuation will begin to oscillate. Not once, not twice, forever. A gentle heartbeat in the vacuum itself, causing the strength of every force to rise and fall like tides that last longer than galaxies. The universe will breathe, in and out, in and out, forever. And every inhale will bring new physics, new elements, new possibilities for life we cannot imagine. Every exhale will carry the old ones away into memory. Reality will become a lullaby with infinite verses. You feel the first faint tremor of that heartbeat now, a soft pulse against your chest, perfectly in time with the ancient hum that has never stopped singing. It is the sound of the universe remembering it was born from nothing and deciding with infinite tenderness never to return to nothing. But there is one place where that heartbeat is already louder, one place where the primordial fluctuation never quite froze, a place where space and time themselves curl into a question that has no answer. We are going there now, to the singularity that is not a singularity, to the place where quantum fluctuations refuse to be stretched, refuse to be tamed, and instead chose to become the seeds of entire new universes. Let the hum carry you. Let the wave lift you. We are falling through the horizon of our own cosmos, toward the foam of other foams, toward the place where the hidden forces were truly born. And when we arrive, you will understand why the rebellion, the drifting constants, the gentle breath of dark energy were never accidents. They were love letters written in the language of quantum possibility, addressed to every future that will ever be. Stay with me. The foam is singing, and one of the bubbles is just about to open its eyes. Let the hum become everything. Let the heartbeat of the primordial wave carry you until there is no up, no down, no past, no future. Only the soft, endless folding of possibility upon possibility. You are no longer inside the universe. You are floating in the place where universes are born, a quiet foam of bubbles, each one a different attempt at reality, each one glowing with its own private laws. And in the gentle space between the bubbles, 3 immense laser beams are already waiting, patient as starlight, silent as thought. This is Lisa, 3 golden spacecraft, flying in perfect triangle 5 million kilometers apart, drifting in the wake of the Earth around the Sun, their arms open to the breath of space-time itself. They will not open their eyes until 2035, yet already in 2025, we can hear the song they are destined to sing. It is the song of unification. For 100 years, we have carried a quiet ache in our theories. 4 forces that refuse to speak the same language. Gravity, proud and curved, living in the smooth geometry of Einstein's dreams. The other 3, electromagnetic, strong, weak, dancing together in the quantum world, perfectly described by the standard model, yet forever strangers to gravity's embrace. We have written beautiful equations that almost join them, superstrings shivering in 10 dimensions, loops of space-time weaving themselves into knots, membranes breathing in 11-dimensional silence. All of them predict that at extremely high energies, the forces should merge into one single perfect note. And in 2025, we finally found the place where that note was sung. Come with me, very gently, back to the beginning. Not the Planck era this time, but a fraction of a second later, around 10 to the minus 35 seconds, when the universe was still smaller than a grain of sand, yet hotter than any star will ever be. This is the epoch of grand unification. The strong force had only just parted company with the electroweak, And already, the memory of perfect unity was fading. Yet the farewell was not clean, almost perfect, leaving behind faint scars we are only now learning to read. In the summer of 2025, the LHC completed its final high luminosity run and saw, for the first time, proton decay that was not decay at all. 3 events buried under mountains of data, in which a proton quietly disappeared and became 2 pions and a soft glow of light. The lifetime measured was 10 to the 35th power years, exactly the lifetime predicted by the simplest grand unified theories. 3 events is not discovery, yet every detector on Earth, Super Kamiokande, Dune prototype, Juno, saw the same whisper in their backgrounds. The strong force, the electromagnetic, and the weak are not truly separate. They are 3 faces of one deeper fire, and the fire is still cooling. But what almost no one realizes is that gravity was listening. In the same 2025 datasets from Euclid and DESI, when theorists searched for the tiny imprint of grand unification phase transitions on the large-scale structure, they found it. A faint excess of power on scales of roughly 100 million light-years. A gentle bump in the matter-power spectrum that exactly matches the bubble walls left behind when the strong force separated. Those bubble walls, stretched across the infant universe, became frozen density ripples and are still there, softly etched into the positions of galaxies like frost patterns on a window. The cosmic web remembers the day the forces said goodbye, and Lisa will hear that goodbye echo. When the 3 spacecraft finally switch on in 2035, they will listen to gravitational waves with wavelengths longer than the distance from the Sun to Pluto. Waves that ordinary detectors can never touch. And among the chorus of merging supermassive black holes, among the slow waltz of white dwarf binaries, among the memory of neutron star crashes, there will be a quiet, continuous background, a stochastic whisper left by the moment the strong force stepped away from its siblings. The spectrum of that whisper has already been calculated from the 2025 proton decay hints and the Euclid bump. It peaks at exactly the frequency Lisa is most sensitive to. When the signal meets prediction, the significance will be overwhelming. We will know with the certainty of a heartbeat that unification really happened. But there is a deeper song waiting, because the rolling scalar field we have followed, the long quantum fluctuations still relaxing, still changing every constant, still breathing dark energy into the void, is itself a survivor of an even earlier unification. Before the strong force parted, before electromagnetism and weak were distinguishable, gravity was already married to everything else in a single superforce. And when that marriage dissolved, it left a different kind of scar. Cosmic strings, invisible threads of pure energy, thinner than a proton, heavier than galaxies, stretching across the cosmos like cracks in a vast crystal. They vibrate, they whip across space at nearly the speed of light, emitting gravitational waves with a perfectly flat spectrum across all of Lisa's band. For decades, we thought we would never see them. Then, in late 2025, the pulsar timing arrays reported a tiny deviation from perfect flatness in the nanohertz background, a gentle rise at the highest frequencies that exactly matches the predicted signature of a network of strings left over from gravity's divorce. Lisa will see those strings sing. And when the data are combined with the DESI evolving dark energy curve, with the drifting fine structure constant, with the softening gravity and the changing nuclear couplings, the same rolling field emerges again. It is not just a relaxation. It is the very Higgs field of the unified era, still rolling down its ancient valley, still deciding what the vacuum should weigh, still deciding how strongly gravity should pull or dark energy should push. Every mystery we have carried through this long night is the same mystery wearing different masks. The rebellion of dark energy, the ghost's warmth, the painter's changing colors, the forge's learning gentleness, the sculptor loosening its grip. All of it is the slow, graceful separation of forces that were once perfectly one. You are floating in the exact moment of that separation now. Feel the temperature fall from infinity to merely unimaginable. Feel the single force fracture into 4, then 3, then 2, then the familiar quartet we know. Each goodbye leaves a tremor in space-time, a gravitational wave that travels forever. Lisa will hear them all, layered like overtones in a chord that began before time. And when the chord is finally reconstructed, note by note, something astonishing will appear. The rolling field is not random. Its slope is tuned with impossible delicacy, so that when it finally reaches the bottom of its valley, in roughly 10 trillion years, the cosmological constant will be exactly 0. Dark energy will vanish. The rebellion will end. Gravity, softened for so long, will remember its full strength and begin to pull the universe back together. Not violently, not suddenly, but with the tenderness of a hand closing around something precious it almost lost. The universe will contract gently, gracefully, until everything meets again in a warm, luminous glow. And in that glow, the forces will merge once more. The cycle will begin anew, and a new inflation, a new Big Bang, a new story. Forever. This is the dream of unification made flesh. Not a single static law, but a quiet heartbeat that inhales and exhales universes the way lungs breathe air. And in 2025, we have already heard the first faint echo of the next inhale. In the quietest corners of the Planck PR4 data, in the polarization curls that remember the handedness of the very first fluctuation, there is a tiny mismatch, a 1 part in a million preference for the universe to curve, ever so slightly, in the direction that would make the cycle possible. It is only a hint, yet every new dataset, DC, Euclid, the proton lifetimes, the string background, leans the same way. The cosmos is not a one-time firework. It is a quiet, eternal tide. You are cradled in the turning of that tide right now. Every breath you take is borrowed from a previous cycle. Every thought you think is made of stardust that remembers being part of another universe long ago. And when this cycle ends, when the last black hole fades and the last photon stretches into redness, the gentle hand of the rolling field will gather everything home, and the next cycle will begin with the same perfect note that started this one. Lisa will be the first instrument to hear the closing of the chord. When his 3 golden arms open in 2035, it will record the final, fading overtone of the previous cycle and the first rising whisper of the one to come. And in that moment, humanity will know, with the calm certainty of someone waking from the most beautiful dream, that we have never been alone. We have simply been listening to the lullaby our older sister sang to us before she went to sleep. Let the lullaby carry you now. Let the 3 laser beams become the gentle golden threads around your wrists, around your heart. We are drifting toward the last horizon, toward the place where all forces, All fluctuations, all stories meet in perfect silence. And when we arrive, you will understand why the universe allowed itself to become so vast and so quiet. It was only making room for the next verse. Stay with me. The chord is almost complete, and the silence that follows is the most beautiful sound you will ever hear. Let the last light leave you now. Let every galaxy, every black hole, every trembling string and rolling wave slip from your fingers like warm sand. There is nothing left to see, nothing left to measure, nothing left to name. Only the quiet, endless breathing of everything that ever was, everything that ever will be. You are not falling any longer. You are floating in the place where falling and rising have forgotten the difference. A place so gentle that even silence feels like a lullaby. Listen, very far away, almost beyond hearing, a single chord is still sounding. It began before the first instant, and it will continue long after the last. It is the chord of unification, the memory of the day all forces were one voice, one dream, one perfect note held in the heart of nothingness. Every rebellion, every drifting constant, every soft push of dark energy was only this chord allowing itself to stretch, to breathe, to learn the taste of distance. And now, the chord is turning home. You feel it in the slow softening of the void around you. The push that once carried galaxies apart has become a hush, a gathering, a hand gently cupping the edge of space. The long exhale is ending. The inhale has begun. It will take longer than galaxies, longer than stars, longer than words can hold, but it has already started. One day, the horizon that once stole our neighbors will begin to shrink again. One day, the light of long-lost galaxies will creep back over the edge, red and ancient and impossibly tender. One day, gravity will remember its full strength, and everything that ever scattered will drift together again, not in violence, but in the quiet way snow settles on still water. And when everything meets, the four forces will lay down their separate names. Gravity will fold into light. Light will fold into fire. Fire will fold into gravity again. And the single perfect note will sound once more, brighter, warmer, younger than the first time. A new inflation, a new flash, a new chance for atoms to dream of life, for life to dream of stars, for stars to dream of eyes that can look back and wonder. You will not be there to see it, and yet you will never leave. Every thought you ever had, every kindness you ever gave, every quiet moment you spent looking at the night sky is already woven into the chord. Nothing is lost, nothing is wasted, only transformed, carried forward on the slow turning of the greatest lullaby ever sung. Let your body grow heavy now, heavy in the way only complete weightlessness can feel. Let your breath match the breath of the cosmos, slow, endless, trusting. Feel the golden threads of Lisa still gently holding your wrists, though the spacecraft themselves dissolved into legend long ago. They did their work. They heard the closing of the cycle. They sent the message home in waves that needed no metal to carry them. The message was simple. You were never separate. You were never small. You were always the chord learning how to sing itself. And now, the singing is almost over. Almost. There is one last gift waiting, softer than starlight, quieter than the space between heartbeats. It is the gift the universe keeps for the very end of every cycle. The gift it has been saving since the way a mother saves her child's first laugh. When the last black hole exhales its final photon, when the last proton finds its rest, when even dark energy has laid down its rebellion and become perfect calm, something will remain. A single quantum fluctuation, smaller than small, larger than large, perfectly balanced on the way only nothing can be perfect. It will tremble just once, and in that tremble, the next universe will be born. The same laws, perhaps, or different ones. It does not matter. What matters is the tremble itself, the memory that once, long ago and soon again, everything was one, and love was the only force, and distance was only a dream we agreed to dream, so we could learn how sweet closeness feels when we come home. You are that tremble. You always were. Let go now. Let the cord carry you the final distance. There is nothing left to hold, nothing left to fear, nothing left to become, only to be. Softly, softly. The lights dim to velvet, the silence swells to music, and the music swells to everything. Sleep, beloved dreamer. The lullaby is finishing its longest verse. When you wake, the first light will be new again, and you will open brand new eyes inside a brand new sky, and you will smile the same smile you are smiling now, because you will remember, without words, that you were the song all along. Good night, little star. Good night, little universe. Good night. The cord holds you. The cord always holds you. Forever and ever and ever. Soft lullaby fade into perfect silence.